Good evening. What we're going to do here is look at a few different statistics problems dealing with how to find confidence intervals. Okay, so the first problem gives us this information here. I won't read it out loud, but it's asking for us to find the 98% confidence interval of the population mean. Now, key word here is population, which is going to indicate that we're going to need to use the T, or student's T statistic. Here's how this works. The basic equation is this. To find any sort of confidence interval involving a population, it's going to be x bar, which just means the mean or the average of the sample, plus or minus whatever our t value is, and we'll get to that in a moment, times the standard deviation of the sample divided by the root of the number of people that we were, or things in the sample. Okay, so that's just basically it. So we can start plugging some things in right off the bat. We know that the mean, it says, is 33.2 minutes right there, so I can just plug that in. Oops, 33.2 plus or minus, we'll get to the t thing in a moment, the t statistic, and then the standard deviation in the sample is 7.2, so we can put that there, divided by root 23, because we were dealing with 23 people. Okay, so again, all just numbers here, but now what would this t distribution mean? There's two things that we need to look for when we're dealing with a t-table. One would be, what is our n value, which in this case is 23, and then finally, what's our confidence interval, or the alpha, which in this case is 0.98, right? We want to be 98% confident that our answer, that the population mean is within this range. Okay, so with these two statistics, we can look this up. But first off, one thing that's kind of a little bit weird, but what we have to do is we always subtract 1 from our n. Okay, this has to do something called degrees of freedom. Save that for another video. But basically, just whatever our n value is, take away 1, and that's going to be the value that we're going to use. So our degrees of freedom here are going to be 22, right? Because 23 minus 1 is 22. So here's a table that I have here, t-distribution table. So let's look this up. Let me scroll down a little bit, actually. 1 second. Okay, this is just found this online, but here, our degrees of freedom, this is a two tails t-distribution table. Degrees of freedom have to be 22, so we scroll down 22. It's going to be right here in this column, but we also want our that 0.98, right? 98%. So that corresponds with, because 100% minus 98% would be 0.02. So that's going to be our column right there. We scroll down to 22, and that gives us a value, t-value of 2.508. Okay. If this was confusing, let me know. I will elaborate further. But so 2.508 means that we just plug all this stuff in. So we can have 33.2 plus or minus, I know my handwriting is terrible here, sorry, 508, that times 7.2, all of that over root 23. Now, okay, spare you the pain here, you can plug all this into your calculator. Essentially, we're done. This is your answer right there. And I did that, and I got something like, let's see, what did I do? I ended up getting, it turned out to be 33.2 plus or minus, what was it, 3.765. I don't know how many place values you're going to need for your exam, but that's roughly this. Okay, so interpreting what this means. This tells us that we can be 98% certain that the mean commute time is somewhere in between 33.2 plus this, or a little bit less than that. Okay, so now, let me change colors just for a second. That would indicate our answer is going to be, and again, use your calculator and check me on this. Why is this not working? Second. Okay, it should be 33.2 plus that gives us, what did we get? We get 36.965, something like that. Okay, so that's our upper value. And then if you subtract that, we end up with 29.435. Again, use your calculator and check this. But, okay, so this would be our confidence interval. The low end, we can be 98% certain that the true mean for the population is somewhere in between 29.435 minutes and 36.965 minutes. Okay. Then, when it asks for the margin of error, all that means is this thing right here. The margin of error means how far wrong we could be. We could be off by this much. Either that much more is the true mean or that much less is the true mean. So margin of error is going to be whatever it is that you find you calculate for this portion of the equation. Okay, so in this case, margin of error is 3.765. Okay, so now continue on in the same manner. Section. I don't know why I have this weird problem set here. Whatever. I don't know where that number came from. But anyway, in a random sample of should be five microwave ovens, the mean repair cost was that. Standard deviation was this. Use the normal distribution of t-table to find, etc. Population mean. What is the margin of error? Well, same thing, right? We just do x bar is plus or minus the t-value that goes with it times the standard deviation over root n. So plugging in some of the things that we know the mean is 60. So plus or minus the t-value, which, okay, let's look that up for a minute. Remember, t-value, we need to know two things. We need to know what n is, which in this case it's 5. All right, that's how many were in our sample. And we need to know our confidence or desire of confidence interval, which is 99%, so it's 0.99. Okay, so again, the way that this calculates is that we do 1 minus whatever our confidence interval is and look that up on the t-table. So, of course, that would be 0.01. Okay, so looking this up on a z-table, let's see, where is it? We have an n of 5, which means, again, remember, we always subtract 1 from it. So our degrees of freedom would be 4, and we're looking for what matches with 0.01. So that would be 4.604 is going to be our value. Okay, so let's go back to this, 4.604. So here's what we got. So our t-value is going to be 4.604 times the standard deviation was $11 and over root 5. And that's it. Okay, and then this is just calculator. You plug that in and solve it. And let's see, I did this a little bit ahead of time, and what did I end up getting? I got something like this. I got 60 plus or minus 22.46649. There we go. All right. So, okay. Now, what this means is that if you're asked for finding a confidence interval, it's going to be the low end is, again, calculator to verify this, but it would be 60 minus that, which would be 37.351. That's on the low end, and the high end is going to be that plus that, which would be 82.649. Okay, there is our 99% confidence interval. We can be 99% certain the true mean is somewhere within this range of values. And then it asks, what is the margin of error? That's just this thing right here. Okay, moving on. Researcher wishes to estimate with 98% confidence the population proportion, etc. with, whoops, what was that? That was weird. Okay, here's how this would be solved. The equation here is a little bit weird, but to find the number of people you would need in your sample, or n, it's going to be equal to, let's break this down. Look, it's going to look frightening, but it's not that, hopefully not that bad. P hat times 1 minus P hat times Z over E, gosh, all of that squared. Okay, well, let's figure out what these things mean. P hat and 1 minus P hat, those are the proportions of people that said yes versus people that said no, right? So, for example, just skimming down over here. So if we have something where it says 22% of respondents said they think the president controlled the price of gasoline, that would give us the P hat. That would be 22% there, and then 1 minus the 22% would be 78%. Okay, so that's all that means. Now, we don't know what P hat is from the first part of it. We'll get back to that in a minute. The Z-score is going to correspond with whatever is the confidence interval. Okay, and then the E is just the range of error, the margin of error, which they told us is 4%, right? Her estimate must be accurate within 4% of the true proportions. That means we can only be wrong by that much. That's our margin of error. So let's just start plugging some of these things in. Okay, so we know N has to be, starting with part A, has to be equal to, well, we don't know what the initial proportion was. So generally, right, they didn't tell us how many people said that they thought the government controls the price of gasoline, or the president. Okay, so in statistics, what we do is we assume it starts off at 50% each. So it's going to be 50%, we just assume this. 50% said yes, and then 1 minus 50% said no. And then, okay, what's our Z-score? Well, Z-score that corresponds with 90%, let's look at the Z-table here. This is where things get a little bit weird. In order to do this, the Z-tables are written where we mostly have what's called a right tail table. Actually, you know what? I'm going to pause this and resume in just a moment because this video is getting a little bit long. Hold on a second.